Hello everybody, my name is Mike Geig and welcome to another one of our live sessions. This week we are talking about Unity's test tools, which are available on the Asset Store. We're going to talk about how to use them and how to make our games better with them. As is always asked, this is being recorded, so everyone who's watching along right now, this will be available later for you to watch. I'd like to extend a special greeting to anyone from the NSA who's currently watching. Welcome, and I hope you learned something about game development. For everybody else, like always, I will start with saying if you have any questions, comments, anything you wanted to talk about, ask about, anything like that, you can follow us on Twitter, which is a great, quick way to get a hold of us, at Unity3D, at Mike Geig, which is me, at Will Goldstone, and at The Ant Ranch. So any questions, comments, suggestions, anything like that, feel free to pass them along. Or maybe you have some anecdotal information, maybe a haiku. I always enjoy a good haiku or anything like that. Feel free to pass that along. So, what are we talking about today? So today we are talking about Unity's new test tools. Now, these test tools are not built into Unity. They're available on the Asset Store, and I'll actually show you how to access them. And what they are is they are a series of assets that integrate into Unity, into the whatever project you're currently working on, and they allow you to do things like put assertions on objects so we can assert certain situations. It allows us to build integration tests so we can test specific elements of how objects interact with each other, and we can access like an unit and build our own unit testing and stuff like that. Before we start, I want to say that this is not necessarily a coding lesson. We're not going to focus on a ton of code. The nice thing about the assets is they allow us to test without a ton of knowledge of code, which is actually really nice. I mean, we've always been able to test using code because we can write our own tests and things like that, but the testing tools allow us to very simply and very easily build this stuff without all that code, which you know, a lot of people have problems with. Yeah, okay. So, that being said, let me go ahead and show you guys. I'll bring down my Morpheus picture now. I figured you guys would enjoy that. So I'm going to show you real quick how to access these tools, and then we are going to talk about the different components of these tools. As I'm reading the chat, I'm noticing, by the way, that some people are mentioning Unity's new default or sample assets, which are currently in beta. And they are also available on the Asset Store. So just very recently, Unity released a whole slew of new assets, and they're fantastic. So you know, if you're looking for some inspiration, or you're trying to figure out how to do a plane or a car, or for a new first-person controller, third-person, 2D controller, all that stuff, that is all available on the Asset Store. It's all completely free, so check it out. It is fantastic. Okay, so. Real quick, to access our test tools, we're going to go to the Asset Store, and you do that by going to Window, Asset Store, and this will pop up here in a second. Sometimes it takes a moment for it to pop up. My internet's kind of slow because I'm streaming a bunch of stuff. Actually, you know what? While I'm here, let me make sure all the other stuff that uploads to the internet is not on, because that might kill my frame rate. Okay, we're good. Sorry about that. So, in the Asset Store, if I just go to the search bar and I type Unity Test Tools and hit Enter, here we go. Unity Test Tools right here. And these are free. And I already have these imported in my scene. If, you know, obviously if you're following along, you'd want to download and import these. Yeah, and so basically just click Import. And you'll get this nice little folder down here which says Unity Test Tools. Alright. So I just took a sip of water, and of course I apparently fail at drinking water, and now I'm choking. Awesome. Okay, sorry about that. Yeah, I'm probably the only person that could drown sitting up in my basement. Alright, yeah, so one of the questions is, are these assets free to use commercial? And the answer is yes. Now, the the tools, obviously, are not something that you want to be in a production build. So let's get that out of the way. The tools are for testing and making sure things work, but you absolutely don't want the tools in the builds that you actually sell, you know, and put on any marketplaces, because they're test tools, right? They exist to test, and so they will slow things down. So obviously that's not something you necessarily want to do. But okay, so once you import, you're going to get this Unity Test Tools folder, and the first thing to pay attention to is this PDF right here, which is the instruction manual, right? Which is important, right? I'm going to show you how to use this stuff, but do not discount the instruction manual because it's going to have a lot more information on all the various components. All the various components of the stuff. For those asking in chat, no, it's not my mom's basement. I have my own house. So, sorry for everyone who's like, not in your mom's basement. No, I don't live with my parents anymore, sorry. I don't know why I'm apologizing for that. Okay, so we have this. So let's look at the very first thing that I really like. All right, the very first thing I really like is the assert component. And the assert component is going to allow me to assert that something is true. And it's actually really quite fantastic. There's three primary parts. There's three primary parts to this. The first is the assert component, the second is the integration test, and the third is the unit testing. And so we're going to kind of go through these in order. Now everyone in chat's making fun of me. Stop it. All right, so I have a scene here. Let's go ahead and pull up my first scene, which is going to be sort of indicative of my first problem, if you will. So what I have here is I have this little cube, which I call player, all right? And the player has some health, which we can see here is 100. And we also have this spawn object that's going to start dropping some spheres, which I called meteors, onto the player. And every time a sphere collides with the player is going to destroy the sphere, and then the player is going to lose 10 hit points. So if I run this, we can see that some spheres are dropping here, and my health is going down. All right, and that's all well and good. That should not surprise anybody. My scripts are very, just basic stuff. We don't really need to go through them. This is just kind of the basic scene. So what my scenario is, so I'm sort of imagining some test scenarios. Obviously, I can't show you how to do your scenarios because they're all very specific to your game. So here's my scenario. Let's say that I have this game where these meteors fall on the player, and at 50 health, the player is supposed to do something. Maybe the player starts to blink, maybe the player makes a sound, maybe the player changes in size. Something is supposed to happen when my player is at 50 health, and it's not happening. All right, so I'm running my scene, and it's just not happening. And so I can rack my brains all day trying to figure out why the heck is it not happening. Furthermore, I might try to pause the scene, right, while when my player gets at 50 health, but maybe I'll miss it, right? I won't know the exact moment my player goes to 50 health. I won't know, maybe it takes me a second to click this and then he's at 40 health or whatever, right? And so what I want to do is I want to be able to pause my scene the moment the player is at 50 health, right? So I can see what's going on. I can see where stuff is. I can see, hey, why isn't this working? Okay, and so up until now, that's not really something that's been very easy, right? Because I can write scripts to sort of tell me when I'm at 50, and I can output some information to the log, but I couldn't really pause my scene. If I manually pause my scene with my mouse, right, or by hitting Control P, then all of a sudden, I might be late or something might be wrong, right? And so the assert component allows me to do that. And debug.break is a possibility, but then again, there are some limitations of that as well. And also you have to have code in place to do that. And the great thing about the testing tools is you don't need to be a programmer to use them, right? So I'm going to show you how we can make this work. Say I was an artist or a designer, or maybe just someone who didn't understand code all that well. There's actually, I can still use these tools to build asserts without necessarily knowing about coding, right? So what I'm going to do is, I'm sorry, I'm reading chat here real quick. Okay, sorry about that. So what I want to do is I want to put an assert statement on this player, okay? And how I'm going to do that is I'm going to attach a special script. And the scripts all exist in these folders. I'm not going to get into where stuff is in here. For the most part, we're just going to keep this folder closed. What I can do is on my player, I'm going to click Add Component, and I'm going to go to Scripts. And this folder appears, or this drop-down called Unity Test. And everything that has to do with these test tools is in here. So I'll click this, and I find Assertion Component. All right, Assertion Component. And so I'll click that, and I get this new assertion component. Now, this is a very, very powerful, all right, it's a very powerful thing. Which, in the new sample, I'm sorry, I was reading chat, and there was a question, but that's about sample assets. That has nothing to do with this. So I'm not answering a question about sample assets. I just wanted you to be aware of them. And yeah, so we're not talking about that. So assertion component right here, and this is going to allow me basically to use drop downs to choose what I want, right? And so what I'm going to say is I'm going to, since I want to know when my health is no longer 50, right, or no longer, basically no longer greater than 50, right? I'm going to hit bool compare, and I'm going to choose instead of float compare, because I want to compare my health, which is a float. There's a bunch of different compares, by the way. There's bool, colliders, general, integer is rendered by camera, so we know when things are no longer visible by the camera. String, we can compare vectors, all this stuff, right? But I'm going to do a float compare. And now I get to know, when do I want to compare, right? When do I want to see when this stuff happens? All right, so what I'm going to do is I'm going to click Start. The first thing I'm going to do is I'm going to hit nothing, because it's just the same as unchecking Start. So I'm going to hit nothing. And instead, what I want to do is I want to check on trigger enter. You'll see here that my player box is a trigger, right? So I'm doing on trigger enter. If it wasn't a trigger, I could do like on collision enter, and 2D stuff here, by the way. I can do on trigger enter 2D and stuff like that. But this is a trigger, so on trigger enter. Cool. So whenever anything enters the trigger, I'm going to compare player. Since I put this on the player object, it's automatically filled in as the player. And I'm going to say player trigger script, because trigger script is the name of the script that I have on it right here, trigger script. Player trigger script health. So what I'm doing is whenever a trigger is entered, all right, I'm going to look at the health of the player. I'm going to say, is it greater, okay, and then I'm going to compare to a constant value, 50. So every time a trigger is entered, it's going to say, hey, is the player's health, which is part of the trigger script, greater than 50? If it is, nothing happens, okay? Because that's what we want. We are asserting that this is true, all right? I assert that every time the trigger is entered, my health will be above 50. And I'm actually going to change something here. Oh, no, I don't need to. Never mind. So this is what I'm asserting, okay? So let's see what happens. We're going to go ahead and run this. And we will see the spheres will come down. The health is 90, 80, 70, 60, 50. And you'll see that we get a player assertion failed down here. All right? So that's only part of what I talked about, isn't it? We have a player assertion failed. All right? We see assertion exception, player assertion failed, trigger script health compared to constant value 50 failed. All right, great. That doesn't really do exactly what we wanted, though, does it? So next, in conjunction with this, I'm going to click error pause, right here, error pause, which will pause my game when an assertion is thrown. Now let's try it. And so now, here comes the spheres, 70, 60, and boom, game is paused. Now, I know the exact subject, or the exact moment, right, exact moment that something collided with my player and the health was reduced and it's no longer greater than 50, right? Now I can begin looking around and seeing what all is going on. Why didn't my character do whatever it needed to do? Things like that. All right, and so now I can begin fixing and playing around with this and stuff like that. This is like a super powerful feature if you're not a programmer. Like I said before at the beginning of this, testing has been something that coders have been able to do for a while, right? I mean, we can all write code to test, right? But if you don't know a lot of code, this is actually really, really neat, right? This enables you to focus on what you need to focus on without worrying about the code. And the better part is that when I'm ready to ship my game, all I need to do is just remove this component. I don't have to dig through code and find all the things in code and remove them. And I know a lot of the debug stuff won't be there in production stuff, but I mean, but what I'm saying is if I want to clean up my code base, you know, I'd have to find all those things and remove them. As with the components, I can just remove the components, all right? So that makes things fairly simple, okay? If you're not having I'm reading the chat here, some people don't have audio. If you don't have audio, well, you're not going to hear me, but everyone else can tell you. Just refresh the page, or make sure you're not muted, right? Make sure things aren't muted, turn it up. Yeah. Anyway, yeah. So anyway, so this gives us a lot of power here, right? So I can basically say, this is what I want to do, and with a lot of drop downs and stuff like that, makes things very simple, okay? So next, let's say we have an issue like this, all right? So what I'm going to do is I'm going to unpause this. Let me change my script. So next I want to show you guys a bool compare, because that was a float compare. So I'm going to go to my scripts, and trigger script is this particular script. And let's say I just had a line of code in here. So one of the questions, how did I manage to pause the execution? In console, I have the error on pause selected. Waiting for this to open here. Okay, we get it. All right. Error on pause is selected, which causes the assertion that gets thrown to pause the playback. All right. So that's what I mean. That's how I got it to pause. Okay. All right. So. Now, so someone said, what do you mean by digging through code, and what's the difference with debug.break? So debug.break is great if you know how to code or if you know where to put things in your code. I'm not discounting debug.break for everyone who's like, what about this? The assert component is a visual component, which allows me to just mess with it in the editor and not have to come to code. And what I mean by dig through code, I mean, you know, if I put debug.breaks in 100,000 different places in my code, and I wanted to remove those, it gets more difficult. I can do a search for it and remove line by line and all that stuff, but ultimately I have to do that crap, right? Because we're not talking about, a lot of people get confused when it comes to testing, because they're like, well, obviously I know when the sphere hits the cube that this happens, so why do I need these tests? What you forget is this is just a very simplified example. In a real game, situations are very complex, and there's so many components, and there's 20, 30, 40, 50, 100 scenes, and things get very complicated very quickly. So that gets fairly difficult. Someone said having to remove all the asset components in all game objects before release manually is not that great. They actually, if you read the documentation, they get disabled upon build, so you don't actually have to remove them. So that fixes that, right? But anyway, I guess I should have mentioned that. I meant to mention, I was planning on mentioning that later. But yeah, they get disabled on build, so you really don't have to worry about that. But yeah, so if you know, it's all just different workflow. Maybe I want to work in code. Great, work in code. Maybe I don't. This is your option to not. So anyway, so let's come in here and let's just say something along the lines of if health is less than 60, we'll say 70, whatever, then collider.enabled equals, oops, false. So I'm just writing a real simple thing in here to turn the collider off after 70 so that we can see how the bool compare works. So this is nonsensical. There's no reason you'd want to do this, but I just want to demonstrate the bool compare, so this is what we're doing. So don't think like this is a great practice, like, oh, let's just turn colliders off, because that's not really all that simple. All right. For everyone who's agreeing or disagreeing with me in chat, stop. It's really distracting from the people who have real questions. This isn't a conversation on what's appropriate practice and what's not. These are two different tool sets, and you can use the ones you like. I'm not saying you can't, and if you don't like it, don't use it, whatever, right? But anyway, so yeah, we're not preaching here. We're not trying to convince people of stuff. I want to show you how to use these tools in case you want to use these tools. All right, so let's go ahead back here. So now what we have is a situation where after a few hits, the collider is going to be turned off. And so what I want is I want to be notified when the collider no longer is turned on, right? And so what I can do is I can build, what I'm going to basically say is I'm going to say, just to show you, I could keep with the on trigger enter, or I could do update, but what if I want to be sure of like the very split second this happens? I can do on everything, right? On everything means on every possible thing, test, right, to see if this is true or not. And that's great. It's slow, right? Obviously, because we're doing these checks all the time. But if I absolutely have to know right away, then everything is a great way to do that. So what we have is, the first is check after how many seconds, right? So 1 second, right? Repeat check. Yes, we want to repeat, and we want to repeat every 1 second. Check after 1 frame, repeat the check, repeat every 1 frame. So every frame and every second and on every event and everything is checking this. So it's checking this a lot. And what we're going to do is we're going to choose a bool compare, and we want to compare the player. We are going to choose box collider dot enabled, and we're going to we can compare it to another object, by the way, if mine's enabled and theirs isn't enabled or whatever, right? But I'm going to compare it to a constant value, and I'm going to say we're going to assert that it's enabled, all right? And so the second it becomes not enabled, we will be notified, all right? Since 99, I always wondered, I thought making variables public is bad programming practice, so you need developers or bad programmers. No. Actually, we can make fields serializable, which allows us to make them private, but also visible in the editor. We can also, there's stuff, we're just trying to make stuff easy, because we understand that everyone is new, right? A lot of people are new, and they don't necessarily understand security. So it is not that we are bad programmers. Everyone's a bad programmer if you think about it. Everyone has their own preferences and bias and are good at things. And anyway, I'm getting off topic. Anyway, so let's see here. So we're going to be notified the second this box collider is no longer enabled. So we'll go ahead and run this. And these things are going to start coming in. The orbs are going to start coming in. And right there, pauses our game right when this happens. And we are able to figure out exactly why. So again, that's our bool compare. And that's how we check for everything, right? So there's a lot of different ways to make stuff work, and there's a lot of different ways to do all sorts of stuff, right? So yeah, so the assert component is fantastic, okay? As someone like me, I've been waiting for something like this for a long time, because it's just super useful if I don't want to wade through code, or if I'm trying to do something quickly, to just slap an assert component on something and have it pause the game for me when something happens, right? Without worrying about where I'm doing my checks. Like, can you imagine how many debug break statements you'd have to be able to check after a period of time, start, update, fixed update, late update, on destroy, on enabled, on disabled, on controller, right? I'd have to have if statements determining all of these things in every one of these sections with debugged out breaks, right? Instead of with the assert component, where I can put it right here, right? Which makes it really simple and easy to use, all right? All right, so that's our assert component, and this is not the last we've seen of the assert component. We're actually able to use the assert component later in conjunction with our integration tests, right? So that, you know, it's not like we're just going to use it one time and never use it again. You know, we'll be able to use this stuff all the time. Cool. Alrighty, so let's talk about integration tests. The purpose of integration tests, and by the way, I'm not teaching all of the concepts of testing themselves, right? I mean, there are books and books and libraries of books all about what is a test, what's not a test, and all this stuff. All I'm talking about is just how we're going to make this stuff work in Unity. If you really want to know more about tests themselves, please do research on the internet. There's a lot of information. There are a lot of purists. There are a lot of people who like new styles of doing things. There's things like test-driven development. There's just, there's so much to know about testing. We're just talking about Unity testing. And right now, I'm going to talk about integration testing, okay? And the thing with integration testing is all about how objects kind of interact with each other, or how scenes are integrated together, how things are behaving in a world, okay? And that's so important, okay? So there's a lot to this. I'm sorry, I'm trying to read chat and keep my chain of thought at the same time. There's a lot to this. So the first thing to understand about integration tests is they don't go in your regular scenes. Integration tests do not belong in a scene that you're actually building a level in or anything like that, right? Integration tests exist to exist in their own world, right, and for their own very specific corner case situations, right? So let me give you an example. So what I'm going to do is I'm going to create a new scene, because we want to do all of our integration tests in new scenes, all right? I'm not going to bother saving this one. All right. So there are, there are a few different things we can do in here, but ultimately, what we want to talk about is we want to talk about how we can build certain situations to test corner cases. And what I mean by a corner case is I mean something that will happen this way and not that way, right? So edge cases or whatever you want to call them, all right? So the first thing I'm going to do is I'm going to go ahead and I'm going to open up the test runner, okay? So if you imported the Unity test tools, you'll have this thing up here called the Unity test tools, right up here, all right? Obviously this does not exist if you did not import these. Okay, so you gotta have these. So if you click Unity Test Tools, we have a few things. We have the Unit Test Runner, Integration Test Runner, and some options. I'm gonna choose the Integration Test Runner because we're talking about integration tests right now. It would be silly if we weren't talking about integration tests. And this is a window just like any other window. I'm just going to go ahead and dock it. Allow me to dock it. There we go, right there. And that's where I want it. Hopefully, I'm actually watching the Twitch stream right now to see if the window appeared. Because I don't know if it looked weird or not, because sometimes my screen capture doesn't pick up windows. Alright, cool. So now what we want to do, we have our integration test runner right here. We have some things, I'm going to talk about these. Alright, so the first thing we can do is we can add a new test, right? We can run a test, and we can run all of our tests. And then we also have some options and things like that. And a lot of these are covered in the documentation for the test tool, so you can always look at those. One thing we want to pay attention to, the one thing we're really interested in right now, is this add game objects under test. I'm going to uncheck this right now because I want to kind of set up my scene, and I'll add it back later. Okay. So the first thing I want to do is I am going to create other directional light just to have a light in my scene, and I'll just toss that off the way. All right. Now, without any tests in my scene, what I would want to do is I'd want to set up just the things that are common to all of my tests. Maybe I'm making a deathmatch style game, so I might want to set up the arena, right? Because the arena isn't going to be specific to any one test. The arena is going to be shared across all tests. So anything that's not specific to one test, I would add now. When that's done, it's always a good idea to come back to options and check this so that it just gets easy in the future. All right, so we don't need to worry about where our game objects are. All right, and then I'm going to hide that. Okay, so now what we have is we have the ability to build individual integration tests, and each integration test will be its own isolated kind of mini scene. So if I select one integration test, all of the game objects from other integration tests will disappear. And then if I choose another one, that one will appear and the rest will disappear. And so what I want to do is I want to test right now. Let's say hypothetically I have King. I didn't toss the light. I just grabbed the translation handle and moved it. It's still up there. But let's say I want to have a sphere with a high amount of drag. Okay, let's say we're pretending this is some game object and we just want it to have a high amount of drag. Again, these are overly simplified examples, okay, but they are just examples, right? So your game might have a very specific situation. As a matter of fact, the test tools themselves come with several examples based off the Angry Bots Unity demo, where you can see kind of more detailed examples of why they work. But let's talk about a very basic example. So what I'm going to do is I'm going to add a sphere to my scene. So I'm just going to click Create Sphere right here. And you'll see, oh, well, before I do that, I'm sorry, I forgot to create a test. So I'm going to create a new test right here, new test. And I'm going to call this maybe Sphere Drag Test. Okay. And first off, it says what platforms do we want to test on. I'm just going to check. I'm going to leave everything. How long should the test take? If the test takes longer than our timeout, the test will fail. I also have the ability to ignore a test in case I want to turn it off momentarily. And then I have these couple things here, which we'll talk about later. The first is succeed on an assertion. So if an assertion throws an exception, if an assertion passes, the test passes, and then we can tell it to ignore exceptions. So if we have a scene we know when exception is going to occur and we just want to ignore that exception, we can certainly do that. But anyway, so now we have a test, all right? And we get two objects. We get test runner, which is this empty game object with a test runner script, and we get this thing called sphere drag test, which we just created, and this little icon next to it. From now on, when I create a game object, it's going to go under this test. So if I hit create sphere, you'll see the sphere becomes a child object of this test. And I'm going to put the sphere as 0, 0, 0, and I'm going to give the sphere a rigid body. What I want to test is I want to test the drag of this sphere. Maybe I have a custom script on my sphere which allows it to never go above a certain speed or whatever. I'm kind of just simulating that. Again, like I said, real simple tests, okay? And I'm going to set the drag on my sphere to 20. I just want a drag of 20, and I'm going to put the position at 1.5. So I have this sphere, all right? And actually, if I run my scene, the scene will run, because with integration test scenes, we don't actually run them using this. We run them using this, okay? So I have my sphere, and the next thing I want to do is I want to create myself a plane. So I'll go create game object plane, which will again go at 0, 0, 0. So here's my test. Now that I've kind of set up with the assets, this is what I'm thinking. I want to ensure that my sphere drops from gravity very slowly. Okay? I want to prove that it works. I don't want to just say that it works, and I don't want to like run my scene and count 1 Mississippi, 2 Mississippi. I want to know that it works mathematically consistently. All right? So what I've done is I've built this little scene. And I want this to pass if an amount of time elapses and the sphere has not hit this plane. All right? I want it to fail if within a certain period of time the sphere has hit the plane. Okay? Again, very simple test. Okay. So what I'm going to do is I'm going to click on my plane, which I have here. I'm going to make sure it's a trigger, right? Because I want to deal with triggers. And then I'm going to add a new component. And the new component is going to be called the call testing component. So I'm going to click Add, Scripts, Unity Test. Again, that's that new collection of scripts. And Call Testing. And what I'm going to say, I'm going to actually create 2 of those. 1 to pass and 1 to fail. Okay? And the first thing I'm going to say is I'm going to say if after 3 seconds, I am going to pass. All right? And on-call method is going to be call after seconds. So after 3 seconds, we're going to pass this test. The sphere did not hit the plane. We're passing the test. However, here we're going to say on trigger enter, fail. So basically, if this sphere ever hits this plane, we fail the test. If after 3 seconds it hasn't hit the plane, we pass. Okay? So that's easy enough. Let's go ahead and run our scene. Now, again, we don't normally run our scene with this. I just want you to see we're running our scene, and it's falling very slowly, and it hits, and since that's a trigger, it goes right through. Whatever. All right? We even get a little note at the bottom here, integration test fail, but it's just a note. It's not really anything important. So now let's run this as if it was a test. And so what I'm going to do is I can either click here where it says sphere drag test and right-click and run, or I can select it here, sphere drag test, and just hit run, which is what I'll do. It builds the scene and it tests it. 3 seconds passed, the sphere did not hit the plane, and our test passed. We see test details. Test started, test passed, test finished. And this icon turned green. This test is successful. All right? Now, here's the question I will ask you, and it's rhetorical, but I'm going to ask it to you. Why bother with this, right? See, doesn't that feel a little complicated, right? It feels like, man, I had to build a test, I had to add game objects and a plane and these scripts, and all for knowing that this sphere moves slowly. Like, shouldn't we just be able to look at that and see, right? I mean, that's an adequate question, right? You might be asking yourself that, or maybe you're not, or maybe you know the answer. The answer to that is that games tend to be very complex, and generally a lot of more people than just one person messes with that. So while it is easy for me to remember all the situations that I want to happen or don't want to happen in my game, not everyone knows about that. So consider this sphere, instead of just being sphere, as a prefab. Maybe it's a meteor object in a game or something. And someone else comes along and says, why is the drag 20? We're going to make the drag 0. That's what it's supposed to be, isn't it? And then they go and run their tests. And what happens? The test fails. They go, wait a minute, all of my tests passed a second ago, but now my test is failing. What happened? Oh, I changed the drag from 20 to 0. The drag must actually be important. Maybe I shouldn't mess with that. All right? So that is why we do integration tests, assert components, unit tests, right? Is because it's not always just us. We have the rest of our people on our team, and sometimes even we forget things that are supposed to happen, and it's always good to just be able to go, wait a minute, everything I think should be correct is correct. Okay, fantastic, right? I have a green passing test. This is fantastic, right? So you might be thinking to yourself, man, this is stupid. Why would I ever do this? This is so much work. But trust me, on big, complex things, this is actually great. It's like, hey, I'm just going to scratch this off my list. I no longer have to remember this. I don't have to put any thought to this because the test is there, right? The test will tell me if it passes or fails. Mathematically, empirically, unequivocally tells me, yes, this passed or no, this did not. And yeah. And so that is, yeah. So let's look at having multiple tests in a scene. All right. So there we go. That we have that. By the way, we put this call testing right here. Call testing script. Call testing script. We don't necessarily have to just use this call testing. I have this little script here just called pass script, just to show you. It's just there's nothing really in it. But if I put if I put integration test dot pass game object in this scene, in this integration test scene, it will pass my test. And if I put integration test dot fail, passing in game object, it'll fail my test. So I can write scripts to do very complicated tests, integration tests. It doesn't just need to be as simple as, hey, this ran into that, or hey, this happened after this many seconds. I can write really robust, complex tests in here and just use integration test pass and fail to tell it whether or not it passed or failed. All right. So I can say, I don't know, I can be very explicit with it. All right. So yeah, we have a lot of control over that. One question here, with just one run you pass the test for all platforms. That's a great question. If you recall, when I click on the test, I have the option to choose my platforms here. So yes, I have options of knowing what platforms I'm testing for, and so on and so forth. Obviously, if I was testing for like player or inputs from a multiple touch screen, I would not want to test on anything that didn't have a multiple touch screen, or else that test would time out, right? So it becomes very simple. Furthermore, if I go to assets, I can see now that there is this test results XML file, which tells me how things went. All right, so we know more about all this stuff, okay? Oh, you can see a lot of information about my computer, too. Huh, that's cool. My computer's name is Frobus, by the way, in case you wonder why that showed up here. I named my computer Frobus. Okay, so let's get back to what we were working on. So that was one test. Let's look at having multiple tests in a scene. So I'm going to add another test, and I'm going to go ahead and just click this plus icon, boom, just like that. And we're going to see how we can use assert components along with integration tests, all right? So what I'm going to do is I have my new test here, and I'm going to call this one power up test, all right? And I want this to time out after 2 seconds. So it's going to be a fast test. If after 2 seconds I haven't got a pass or a fail, I'm going to assume this fails, okay? That's just what we're going to do. And then what we're going to do is we are going to create 2 spheres. By the way, have you noticed that now that I have power up test selected, my plane and my sphere are gone? See that? Only one test is active at a time. The rest gets disabled. So now with power up test enabled, I'm going to go ahead and add 2 spheres. I'm going to add 1 sphere for starters, all right? Which I am going to put at, let's just do 0, 0, 0. Okay, that's where it's already at. And we'll go ahead and we will add a physics rigid body. So there we go. So it will be affected by gravity. And I will duplicate this, and I'll move the other one over here. And I will call this one, just for the sake of organization, I will call this one big sphere. And I will call this one small sphere. Now I know they're the same size. What we're going to do is we're going to test a power up. And the power up should make one get bigger, double in size, all right? So that's what we want. We want one. I'm sorry, I'm reading through the questions. So this sphere that's being tested is just something in the scene. What if I want to make regression test on my prefabs? Oh, I could have used prefabs. I added spheres, but I could have easily grabbed any prefab and tested it in here. So don't think that I'm just adding spheres and planes and stuff like that. If I was building a robust game, I'd use the actual player objects. I would use all of the prefabs and the scripts from my game. So this is, like I said, is highly it's highly simplified. But no, I would actually really test the actual production game objects and materials and textures and models and all that stuff. So I'm not just messing around with basic stuff. So what I want to do, so I have my small sphere and my big sphere, and I basically want a cube that's going to be my power-up, and when my big sphere lands on that power-up, it's going to get big, and it's going to compare itself to the small sphere, right? So we're going to make sure, hey, this one did get bigger than the other one, and that's what we want. So I'm also going to, I'm going to create a cube, and that cube is going to go at 0, 0, 0, and then I'll move it down to, like, say, there. Works for me. And then I have a script, and I already have this script made. I'm not even going to bother to open it up. It basically just says on trigger enter, okay, which reminds me I need to make this a trigger. I'm going to get the scale of whatever collided with it, in this case this sphere, and I'm going to double it. I'm just going to make it twice as big, okay? So that's what the power up script does, and I'm just going to drop it on there, and I'm going to say, hey, this is a trigger, okay? Real simple. And so when one falls in the other one, it's going to get twice as big. Now, I'll run this just so you see what it does. All right, that's what it does. Okay, this is our very basic scene. And so now what I want to do is I want to build our test on top of this. And I'm going to use an assert component. I could use the call testing and all these other things, but I want to show you how the assert component works in this. I could put the assert component on one of the spheres, but I'm actually going to put it on the power-up. Not saying that that's necessarily a good idea. I just want to do it so you guys can see how it's done, right? So I'm going to do add component, scripts, unity test, assertion component. And what I'm going to say is I am going to test, right, that on trigger enter. So what I want to test is on trigger enter. There you are. On trigger enter, I'm going to basically assert that the local scale X of the big sphere is bigger than the local sphere X of the small sphere, right? Real simple. And again, I can use scripts to make sure that it's double, and I can use scripts, but I don't want to get into scripting too much because I just want to show how this stuff works. So I'm going to use a float compare, and I'm not comparing cube. In this case, I'm comparing big sphere, and on big sphere, I'm comparing the transform local scale, where are you at? Local scale X. And I want to ensure, all right, I want to ensure that it is greater than small sphere. And again, I'm going to the local scale X. Okay, so when this happens, I want to ensure that this sphere doubles in size, gets bigger. Okay, now I'm just going to go ahead and run this real quick, just so we can see what it does. Because we're using the assertion component. We're not using our call testing. We're not calling integration test to pass or fail. So let's just see what this does. So we're going to run this, and it didn't work, right? Did we get our assertion? We didn't get our assertion. It didn't work, right? And we got a fail because it timed out, and we see test timed out. The reason is we didn't tell it to look for assertions. That's what this checkbox is right here. Now, here's the confusing part. Okay, the confusing part is succeed on assertions does not mean this will succeed if the assertion throws an exception. We don't want the assertion to fail because that's still a fail, right? So it's worded kind of weird. Succeed on assertion means that the assertion test was done and it did not fail. All right, so that's kind of a weird way of wording it. So just so you're aware, this means kind of the exact opposite of what you assume. You assume succeed on assertion, well, it threw the assertion, but it failed, right? What's going on? Succeed on assertion means, again, I'm just going to reiterate, that the assertion test was run and the assertion test did not fail, okay? And so it's kind of a weird way of saying it. So I'll go ahead and run this, and boom, test passed. And again, now what I can do is I can at any time load up this scene and I can just run all my tests. And so that's what I'm doing here. That passed, or was about to pass, and I can see 2 tests passed. Oh, down here at the bottom, passed 2. Both of these turn green. I know all of my integration tests passed. All right, and then there's a lot of integration tests that we can run. If I were so inclined, because that's going to kind of wrap up my talk about integration tests before we talk about unit tests. If I was so inclined, I could come down to examples, right, and I could look at my integration test scene. This comes packaged with, and in this you can see that there are a bunch of tests, right? This one is going to test throwing exceptions, assertions, assertion fails, success, timeout, failure, ignored, right? And if I run all of the tests in this scene, we can see how that steps through success, failure, these fail with assertions, these timed out, failure, whatever, right? So we can see how a bunch of these work, okay? So again, just a little, we have another one here. This is the one I thought it was. So this is the one with actual production. This is the angry bots. So we want to see, does this thing damage the player? Does the thing wake up when the player gets there? Does the thing go to sleep when the player's further away? We can run all these tests, and we can see how it works. We can watch these run. So we can see all the different sections, and that they all passed. So these come built in. You can test them out yourself. You can kind of see more in depth how these things might be put together with production assets, because, you know, things get a little bit more complicated. And I'd love to do a complicated example with you guys, but, you know, I don't want to throw off anyone who's new, and I don't want to do anything that doesn't necessarily apply to everybody, so I kind of avoid that. A lot of stuff in the chat here, so 1 second while I read through the chat, because I just want to catch up, make sure I'm not missing anything important. So as Drew Van Camp said, so the tool you're on now is used to see how prefabs interact with scene elements to make sure things behave as expected once everything is working together all at once. Correct, right. This allows us to isolate a few different pieces and make sure they play well with each other without the chaos of an entire scene, right? Because sometimes it's hard to tell. The robot exploded. Why did it explode? Was it because the player was shooting it? Because it was a bug? Because of this? Because of that? This allows us to isolate some things. How would you handle multiple tests that test the player prefab differently? You just build multiple tests. I mean, I don't think you have to. Yeah, so you'd build multiple tests. You would just keep adding tests for each different thing you wanted to test. So each test tests one thing. All right, we don't want a test that tests a bunch of different things. So we create a bunch of tests, right? And again, that sounds like a lot of work, but it basically allows us to just set it and forget it and never have to worry about it again. I'm not sure it's a common test. What happens when the player picks a power up as they simultaneously. Oh, that's just referring to that. Like I said, again, we can use code to make these tests much more complicated and robust. But I'm just kind of showing you that you don't necessarily need code to test everything. Okay, I'm pretty much caught up there. So cool. So the last thing I want to talk about is I want to talk about unit tests. Okay, now unit testing is entirely code. Okay, so I'm not going to get real in depth to that because the unit testing, so the unit testing with Unity's test tools, the tools that I've imported here, use something called NUnit. So if you've done unit testing before, you might be familiar with NUnit. If you have not done unit testing before, you will not be familiar with NUnit. And if I open up our documentation here, and give that a second. We open up our documentation here. We can come down to unit. The nice thing is NUnit's quick start guide is right here. So there's a link on how to use NUnit because it kind of uses its own syntax, right? So it's a little bit different. Okay. That being said, I'm going to show you a very basic unit test. Unit testing is not for testing prefabs, and it's not for asserting anything. It's for testing your code, right? So if I write a class that's supposed to manage all the data of my player, I'll run unit tests against that class to ensure that it's working correctly. Think of unit testing like integration testing, but for your code specifically. Okay? Right? Okay, I'm sorry, reading here. These assertion components, do they have to be inside my prefabs if I want to test my prefabs? No. If you pull a prefab into a scene and then add the assertion component, that won't add it back to the prefab itself. That'll only add it to that one instance. So you don't need to put the assertion on the prefabs themselves. Just on the instances of the prefabs that happen to be in the scene. All right. So that's a confusion a lot of people have there. Okay, so that being said, let's talk about unit tests. So the first thing I want to do is I'm going to come back up to my Unity test tools, and I'm going to open the unit test runner. And again, it's another window. This time I'll just bring it up. You know, I'll just stick it right there, whatever. And you can see there's a bunch of sample unit tests that are built in that came with the test tools. And these are just like the integration tests. I can run them. This also loads you into your own scene. I don't need to save that. And so we can see which ones passed, which ones failed. All right. And these are meant to fail. So slow test was meant to fail. Exception test was meant to fail. These were meant to pass, so on and so forth, right? And so we can see those all specifically. But we can create our own unit test as well. So what I want to do is I just want to show you how to create your own unit test, and I will let you guys learn the NUnit language if you want to build your own unit test, right? Because it's fairly, I don't want to say it's complicated, it's just different, and it's kind of above and beyond the scope of what I wanted to talk about today, especially because it gets into writing your own classes and testing against your own classes. And if you're not really familiar with all that stuff, then there's nothing to really, you know, it's really going to kind of throw you guys out of your way as far as what's going on there. So what I'm going to do is my unit tests have to go into a folder called editor. So I'm going to go ahead and click assets, and I'm going to create a folder, and I'm going to call it editor. All right. And then inside editor, I'm going to create a new class or a new script for my tests. So I'm just going to call this sample tests new, whatever. That's just kind of a weird name. But sample tests new is just going to be the sample test I'm building for here, and we're going to see it appear here once we write it appropriately. So I'll go ahead and open this up. All right, and so go full screen. There we go. That should be big enough. So the first things first is I don't need start and update. I'm going to get rid of that. We're not going to inherit from mono behavior, so we can get rid of that. And I also don't need these, so I can get rid of that. I don't need any of that stuff. What I want, actually, you know what? I might need using system. I don't know if I need that or not. I'm adding it just in case I do. So the very first thing I need to do is say using NUnit.framework. So I know that I'm working with an NUnit framework. I have my class sample test new. And so let's just create a test, right? One very simple, very basic test. Okay. Again, testing gets very complicated. This is a highly simplified version, so don't think that this is indicative of what testing is like really like. This is just a very simplified version just to show you how we set it up, which is, you know, the most important part to getting started. So I'm going to start by saying test. I'm going to create an attribute test. And so what appears next will be the name of a test. All right. And I'm going to say public void. And my test, I'm going to call simple addition. I just want to test addition. This is obviously not going to fail. It's a very simple test. All right. And what I'm going to say, and this is where the syntax of NUnit gets specific, both having the test tag here and saying I'm going to assert .that. So I'm asserting that 2 plus 2 equals 4. All right, obviously this is going to pass. 2 plus 2 equals 4. Great. All right, it might actually fail if I did it as floats, because I believe floats would be like, instead of 4, like 3.999 infinitely, but whatever. 2 plus 2 equals 4. I might be thinking of C++ as well, so now I'm really getting distracted. And so basically I'm going to assert that basic math works. But if I had a class here, I could create a new object of that class and assert that if I gave a player 100 hit points, he would be level 5. And you know, you can get really complicated with that. But this is just basically what I'm doing here. And so I'm just going to save this. I'm going to go back to Unity, and I'm going to allow this to refresh. Maybe open a new scene. There we go. So I have this new sample tests new. Remember, that was the class I made. And I have simple addition. All right, so I'm going to go ahead and just run simple addition. Boop, and it passed. Obviously it passed because it's 2 plus 2 does in fact equal 4, right? And so my unit test can get much, much more complicated, and it's good to organize them in their own classes and all this, but that's really beyond the scope of what we're talking about today. Okay, so at this point, we've looked at the assertion component. we've looked at integration testing, we've looked at using integration testing with the assertion component, and we've talked about unit testing in Unity with NUnit. Okay, again, I'm going to reiterate that allows us to do our testing in a very visual manner using the editor without necessarily needing to go to code. Okay, if you prefer to go to code, do it. I'm not going to stop you. I mean, it's your game. Do whatever you want, right? But this is just more options. And a lot of people were downloading the test tools but didn't know where to start or didn't know how to use them, and so I wanted to show you how. Real quick here, I'm going to look through chat again. I don't know who said anything about new GUI. I'm not using any GUI that you guys don't have. Okay, so it looks like everyone's pretty much caught up there. People are talking about different forms of unit testing, but nothing specific. Yeah. If I have two ways of scripting something falling block, can I test the two scripts against each other to be told which is faster? You can output how long blocks of code take, or you can use the profiler if you have Pro. If you have Pro, the profiler is a great way. By the way, since this is a testing topic, I can show you this. The profiler right here, if you have Unity Pro, is quite fantastic at telling you how long things are taking and so on and so forth. So if I opened up, oh, you know what? I didn't save that one scene, of course, but we'll open up this scene with my assertion statement on it. And if I open up the profiler as well, not the asset store, get out of here, asset store. The profiler, let me just dock it there. I can run my scene. It'll pull up real-time data about how long like everything took. So that's a great pro feature. The profiler is fantastic. But yeah, so I mean, there's a lot of different ways we can do that. Cool. So anyway, that's going to wrap up what I wanted to talk about today. Again, it's the testing tools. Sorry that I was trying to monitor chat and everything, so I tend to be a little bit scatterbrained when I do that, because there's a lot of people talking, especially when it's topics like these. And so basically, just remember this. Any situation you want to test for, you can. A lot of people are like, what if I want to test for this? Can I test for that? Yes, the answer is absolutely. You can test for anything, right? The problem comes from determining exactly how, okay? Some tests are too complicated for visual, and you need to go into code, right? I mean, that's fine, but you can still write code to work with your integration tests, right? I showed you guys how to do that. So the answer is always that you can test anything you want, okay? And so it's just a matter of figuring out exactly how you want to achieve that effect and how you want to build that test, right? Okay. Okay, one question. Which of these tools are available for non-pro users? Okay, so everything I showed you today, except the profiler, is available to Unity free. The profiler is a pro feature, and it's amazing. So just throwing that out there. If you're having some performance issues, the profiler is totally worth the cost of pro in and of itself, because it's fantastic. But everything else is free. So yeah, if you had any questions about that, the rest of the stuff is free. So that's going to sort of wrap things up today. I will hang out and chat a little bit longer if anyone had any questions. But thank you all for watching. I certainly appreciate it. I know a lot of people were kind of confused about what this session was going to be, and so it ended up we ended up losing some people. By the way, Wednesday, so 2 days from today, right before Global Game Jam, I'm building an infinite runner 2D platformer during a live session. So Wednesday at 2 o'clock Eastern time, again, another live session, Infinite Runner. If you're interested in learning how to make an Infinite Runner or working with the 2D tools or just getting amped up for Global Game Jam, come check it out. It's going to be awesome. So I just wanted to throw that out there as sort of an FYI for everybody. So I hope to see you here for that. And certainly appreciate everyone watching. And you all have a fantastic week.